That last one was 17.2, right?
Yes. So this is 17.4, and in 17.4 we'll learn about adding, subtracting, and multiplying radicals. But like I said, I like this section because it's just extra practice with breaking down radicals. So it's basically practice of last lesson and the 17.1 lesson. All right, so real quickly, recall when adding or subtracting polynomials, in order to combine, we must have like terms. And remember, like terms are when the variable part of your term looks exactly the same. So looking at A, what do those two things combine as? What will that answer be? 9x, right? Because they both have an x, so with 7x plus 2x, you have 9x's. B's are identical. They both have an xy behind it, so we can just do the math with 4 minus 8, negative 4xy. And then C is just there to remind you that sometimes you have multiple terms that are like terms, right? So in this case, the 3x squared and the 2x squared, what's 3x minus 1? Or 3 minus 2 is just x squared, is that okay? But then what's 4x minus 9x? Negative 5x. Can we go any further? No, because they're not like terms. This section's identical to that. In order for you to be able to combine them, the radicals have to be like radicals, all right? And sometimes when you look at them, it's very obvious. So look at A. Do you guys agree that there's 2 root 3's there? Do you have a root 3 here and a root 3 there? So how many total root 3's do you have? 2. Well, you have 2 terms, but you have a 7 and a 2. So you have 9 root 3's present. Right? So you have 2 terms that have root 3, but this is really 7 root 3's, and this is 2 more, so you have 9 root 3's there. And that's your answer. Looking over here, do you guys agree that this has the cube root of 5x and this has the cube root of 5x? So they're called like radicals, so you just do the math with the coefficients. What's 4 minus 8? Negative 4, so this is negative 4 cube root of 5x. We're just basically mimicking A, B, and C above, right? On the last one, notice you have 2 terms that have just the square root of 5, and then you have 2 terms that have the cube root of 5. So we can combine the square roots. What's 3 minus 2? 1, but we don't usually write that as a coefficient, right? So that's just going to be root 5. And what's 4 minus 9? Negative 5, what? Cube roots of 5. So you honestly just kind of treat your radicals, even though these radicals are numbers, like square root of 5 is an actual number, it's 2 point something, you treat them like variables, basically, all right? Sometimes you look at them, for instance, D, and you're like, well, they're not like radicals, so I just leave it alone. Break it down first before you judge too soon, okay? So how does root 50 break down? What are any 2 numbers that multiply to be 50? 25 and 2. But why does that help us? What does 25 split up as? 5 and 5. So who can come out and play? 5. A 5. Who has to stay in? 2. So this is 5 root 2. Are you guys okay with that? Minus, we're just going to go back and do the exact same thing with 72. We have to be careful that whatever comes out is going to multiply by that 5 that's already out there, okay? So what are any 2 numbers that multiply to be 72? 2 and 36. Why does that help us? What's the square root of 36? 6, right? And you could stop there noticing it's a square root, but I always like to be careful and just cover all my bases, and I break everything down, just in case an extra 2 or a 3 would come out. Alright? So since it's a square root, a pair of 2's can come out, and a pair of 3's can come out. That looks really confusing. So a 2 will come out, and a 3 will come out. Well, what's technically coming out? A 6, right? But as they come out, who do they have to multiply by? The 5. So you have 30, the square root of 2 there. Does everybody see where 30 came from? You had a 2 come out and a 3 come out, so you had 6 come out. But what's 6 times 5? 30. Who's the lone guy that remained inside? That little 2. And notice now that they're both root 2's. So now that you've broken them both down, you can combine them. What's 5 minus 30? Negative 25 what? Root 2's. Did I skip too many steps there to get that 30, or are you guys okay with that 30? Do you see where that 30 came from?
Yeah, the 6 times 5.
Yep, the 6 times the 5. Yep. All right, so on E, it's the exact same idea. Initially, when you look at it, they don't look like radicals, but if you break them down, they are. How does 98 split up? Two and 49, and why does that help us? What does 49 split up as? 7 and 7. So as the 7 comes out, who's he going to multiply by? That negative 5 that's out there. All right? So this will be negative 35 root 2. Because the 2 didn't have a friend, he stays inside, and the 7 is going to come out and multiply by that negative 5 that's out there. Minus the 72. Let's break 72 down. We already kind of did it over here. It was 2 and 36. But 6 broke down to 6 and 6, which broke down to 2 2's and 2 3's. Loop-de-loop, okay? So who's going to come out? A 2 and a 3. So technically what's coming out? 6. And who's staying behind? A 2. And at that point, again, even though square root of 98 and square root of 72 did not look like radicals initially, they are. They both break down to some form of root 2. So what is negative 35 minus 6? Negative 41. Negative 41 what? Root 2's. Is that okay? They're just going to make them uglier and uglier, but just make sure every part of the match. Make sure every U, every V, every W looks the same. So on S, 6U squared is already out there waiting for you to bring out friends, all right? So how does 24 break down? 12 and 2. And how does 12 break down? 6 and 2, right? And then 6 would be 2 and 3. So since it's a square root, who are we looking for? Pair. Okay? And remember, when he comes out, he's going to multiply by that 6 that's out there. So who stays inside the 2 times the 3, or 6 is going to remain on the inside? Who comes out? That 2, who's going to multiply by that 6. So what are we going to have on the outside? We're going to have 6 times 2, or 12. Let's look at the U. Can any U's come out and play?
No.
None, right? There's one in there, but he needs a friend in order to come out and play. So he's going to stay inside, and that U squared on the outside is going to stay a U squared on the outside. What about that V? How many V's are there? There's 2, right? So 1 will come out, exactly. So remember the divisibility rule, 2 goes into 2 one time. So a V will come out. All right, let's see if we can remember who all is still in there. It's still a square root, and we still have this 2 and this 3, so we still have a 6 on the inside, and that U didn't come out. It can get really complicated. Does that look okay? So the 2 and the 3 stayed on the inside, so that's why there's a 6, and the U didn't come out, so that's what. So, guys, when we go to do the second part, not only does it have to have the square root of 6U match, but it also has to have U squared V match. Like all of this whole chunk behind the 12 has to match if we're going to combine it. Okay? So the 6 was already out there. We pulled out a 2, so 6 times 2 was 12. The U squared was already out there. We couldn't pull a U out, so the U squared stayed U squared. The V squared was a pair, so he can come out as 1V, which left the 2 times the 3, or the 6 on the inside, with the U. On 54, were there any two numbers that multiply to be 54? 6 and 9, and 6 will break up as 2 and 3, and 9 will break up as 3 and 3. So what's going to come out? A pair of 3. All right. Keep the sign the same. So since this is plus b, blah, 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 this is going to be plus. Who's coming out? This 3. And then let's try to keep things in order. So even though we know the v is already out there, in this first term, the u was first. So let's focus on the u. Can any u's come out and play if we have the square root and we have u to the 5th? 2 can come out and play and 1 will remain, right? So remember that rule is this is a square root. 2 goes into 5 2 times. There's no v's to come out, but there's already a v out there, so you have a v. Is everyone okay with that so far? And I'll repeat all of this. So who's going to remain under the square root? This 2 times 3, which is 6, and what else will we have? A u. That u is because 2 does not go into 5 evenly, right? 2 goes into 5 2 times, so 2 can come out with a remainder of 1. Your remainder always lies on the inside. So do you guys see how it also has the u squared v square root of 6u? That whole chart has to match, but it does. So what's 12 plus 3? 15. So your final answer is 15 what? 15 u squared v square root of 6u. How ugly can that be? 15 u squared v square root of 6u. But you guys did it. At first they didn't look like they were alike, and sometimes they won't be. You'll break them down, and they won't be. You just leave them as is, but you always have to break it down. Does anybody have any questions about any part of that?
Yeah, how'd you get 12?
The 12 was because we had the 6 waiting for the 2 to come out. So we had this 6 waiting, and then the 2 came out and multiplied.
Oh, okay,
So
okay, I
there's
gotcha,
12.
okay.
All right, guys, G's going to be the same thing, where as long as there's the same amount of R's on the outside as there are R's on the inside and all that jazz, we're going to be able to combine them, okay? So 24, we just split them up over here. It was 12 times 2. And 12 was 6 times 2, and 6 was 3 times 2. But now what is our index? Our index is now 3, so we're looking for triplets. Do we have triplets of anything? 2's, and when he comes out, who's he going to multiply by?
9.
That 9. Okay? So we have 9 times 2, or 18. Is that okay for the number part? That 3 will remain on the inside. All right. We have 1 R waiting for some more R's to come out and play. How many R's can come out and play? 3. Well, not 3. 3 will hook arms and come out as 1, right? Because 3 goes into 3 1 time. We already had an R waiting, and then another R is coming out. Is that okay, guys? So this R is because we had the R waiting, and this R is because 3 goes into 3 1 time. Who remains under the cube root? I think only one thing. Is it 3? Is that right, guys?
Mm-hmm.
He's out there, he came out. All right, so I'm going to rewrite him as what's that going to be? 18R squared cube root of 3. Does that look okay? Right below him? And you can do that right off the bat. If you know you have an R there, the R's coming out, and you know it's R squared, you can write it. I kind of like to show all my parts. All right, so then this is going to be plus what? Well, cube root of 3. Is the 3 going anywhere? No, he's going to stay the 3. But how many times does 3 go into 6? Twice. So we have the 2 hanging out, and R squared can come out, because 3 goes into 6 2 times. And who's going to still be under the cube root, though? 3. The 3. The 2 was already there, so he's hanging out. The index 3 goes into the exponent 6 2 times, so 2 R's can come out, so that's why R squared's there. And the 3 had no friends, so he has to stay inside. But notice they both have R squared cube root of 3. R squared cube root of 3. So 8, what came out for our Y value? 2. So if we were to graph this, 8, 2 would be on our graph. Just so you kind of try to connect the dots for you, okay? F of 6 is the same thing. Since it's the f function, we're going to use this function over here, which is the square root of x, which is 6 minus 4. You put that in, and you just get the square root of 2. And these, are there any questions on the front there, guys? Let me know, okay? I know it's a lot to take in, but you guys are doing really well, okay? This is the same idea, we just get nervous because we have fractions, but remember our calculator will do our fractions for us. So what we want to do is we want to break 45. I'm going to kind of do an upside down factor tree, if that's okay. What are any two numbers that multiply to be 45? 5 and 9. But why does that help us? Because 9 splits up as 3 and 3. So who gets to come out? A 3. So we can rewrite this as 3 root 5 over 4 minus root 5 over 3. Is everybody okay with that? 3 root 5 over 4, because 9 split up to 2 3s, so he came out. And then 5 doesn't have any friends, so he stays like this. So how do you do this? I know it kind of looks weird, but your coefficients are there. They just don't look that obvious. Your coefficient is the fraction in front, okay? So the coefficient of root 5 technically is 3/4. And what's the coefficient of this guy? What number is technically right here in front of this root? A 1. Do you guys see that? So our coefficients are just really 3/4 minus 1/3. I know it looks weird, but I'm going to write it that way. 3/4 root 5 minus 1/3 root 5. Whenever you have fractions, that whole fraction is your coefficient. And then just do the math on your calculator. Do 3/4 minus 1/3, hit math frac, and you'll have your new coefficient. 5/12. So this is 5/12 root 5 like this, or 5 root 5 over 12. You can do either or, right? You can leave it as that coefficient looking 5/12 root 5, or realize you multiply straight across the top, straight across the bottom. So it's just 5 root 5 over 12 there, all right? But just make sure you just grab those coefficients from the front there. If there's no number up top, it's automatically a 1. All right, this next one, guys, we have a little bit of work we have to do before we can get this root 7, cube root of 7x here. So he's going to hang out as we break the 56 and the 27 down, okay? So I'm going to do an upside down factor tree. What are any two numbers that multiply to be 56 and you can't see it? 8 and, what did you say, 7? And then 8 is 2 and 4, and then 4 is 2 and 2. Does that look okay? So upside down factor tree, 56 is 8 times 7, and then 8 was 2 times 4. So what are we looking for? We're looking for triplets since it's a cube root, so who can come out? A 3, or excuse me, there's 2 3s, so a 2 is going to come out. Who has to stay on the inside? A 7 and an x. So I'm going to write this first fraction as 2 cube root of 7x over, so I'm kind of breaking them up a little bit there. Is that okay? The 2 came out, the 7 can't, and the x can't. And what's the cube root of 27? Do you guys have that memorized yet? 3. If not, you throw it in your calculator, right? So he comes out, and he comes out completely. So he's not under the root anymore. He's just on the denominator. Do you guys see why things are where they are? The 56 was the numerator, so however it breaks down stays in the numerator. And the 27 was in the denominator, so however he breaks down stays in the denominator. All right? And then what do we have on the back? Just 2 cube root of 7x. But do you guys agree that they both have a cube root of 7x there? So what are the coefficients that we're going to combine? What's the coefficient of the first cube root of 7x?
2 over 3.
2 over 3 plus 2. Yep, so put that in your calculator. 2 over 3 plus 2, hit math frac.
8/3.
Yep, so this is just 8/3 cube root of 7x, or 8 cube root of 7x over 3. And that's it. Okay, so we'll stop there and we'll finish this on Monday.